Hello students, good afternoon. Today in this session we will discuss operating system and its functions of the course MCS 041 Operating Systems Block 1 Unit 1. I am Professor Subrahmanyam, Director, School of Computer Information Sciences. Let us start the session. In this session, the basic agenda is to discuss the components of a computer system, what is the significance role of operating system, how we can define the operating system, what are its functions, how many types of operating systems are available. So, this particular topic covers the whole unit 1 of block 1 of MCS 041. To start with, the computer system is basically consists of 4 main components. First one is the hardware part, the operating system, application programs, and fourth layer is users. So, one by one we will discuss. So, this is the actual architecture what we are talking about. In the central, that is in the nucleus part, we have the computer hardware. In the next layer, operating system, application programs, and users. Normally, users are interacting with the application programs. Also, they may give directly the commands to the operating system, and the operating system obviously alerts the hardware, computer hardware, and then whatever the command that is being given, it will fulfill the requirements. So, hardware means it provides the basic system resources. So, in the hardware, whatever that we can touch and feel, the circuitry, the monitor, RAM, ROM, then the keyboard, the external hard disk, everything comes under the hardware. So, these are called as the basic system resources, which needs to be given to the user or else the processor in order to process the data. So, then comes the system software. In the software, as we know, there are two parts. One is the system software and the other is the application software. This particular thing already we had seen in the first semester courses. So, what exactly is the system software? It is the software which includes the compilers, loaders, linkers, debuggers, especially the operating system. So, it refers to the operating system and all utility programs that manage the computer resources at a lower level. So, the system tries to understand only the machine language, which it is very difficult for the human or else the user to interact with the machine using the machine language. So, there should be an intermediate layer or else an interface which understands the command that we intend to give. As per the command, it should manage, access or else activate the computer resource in order to get the work done. So, directly we can't interact with the system, the dummy box, the black box with the machine language. However, we are using a kind of command which will be interpreted by the operating system in turn, and then it will does the work on the behalf as per the command given. So, operating system itself or else the only thing is not a system software. However, there are several things, whichever the software that manages the computer resource, we can call it as an operating system, like the compilers, the loaders, linkers, debuggers, the drivers, everything comes under the system software part. So, this system software is very much nearer to the actual hardware part. So, that actually interacts the software actually interacts with the hardware. Then comes the application programs. These particular application programs are very much nearer to the users. These are not nearer to the hardware, however, these are nearer to the users, wherein which actually the user works with the application programs and designed for the specific purpose, like word processing package or else graphic package, spreadsheets, databases, games, graphics, whatnot. All these comes under the application programs. So, at the user level, he or she will interact with the application program. In turn, those will be understood by the system with the help of the operating system, and then the things will be getting done at the hardware level. So, after hearing the system software, what are the goals of the operating system? Basically, there are two goals of the operating system, of any operating system, maybe it is Windows, Linux or else mobile operating system also. What it does? It makes the computer system convenient to use. So, it provides a kind of environment with a graphical user interface or else any command user interface, and on that particular interface we will give appropriate commands using the keyboard or else using the mouse or else using the key in position. So, we will try to provide the commands, and this particular system gives a convenient form or a convenient environment to use that system. The other thing is to use the computer hardware in an efficient manner. So, each and every program in execution is called as a process. So, whenever they reside in the RAM, there are several processes waiting for the CPU, and then maybe for other resources also, whatever those are attached with the system, like a printer, hard drive, external hard drive, a pen drive or else a CD drive, whatever the case may be. They may be either CPU bound or else IO bound programs or else mixed programs, wherein which they try to access the hardware also. So, this particular operating system gives or else provides a very good atmosphere, wherein which the complete hardware can be used in an efficient manner. One is convenient to use and the other is to use the computer hardware in an efficient manner. Then comes what exactly is the purpose. The purpose of an OS is to provide an environment in which a user may execute his programs. Ultimately, whatever the packages or whatever the application programs that we wish to run on our system, so it should have a convenient environment. First of all, it should open after activation, then it should be giving us a chance to work with the application software, and later on behind the screen the OS will be understanding the commands and it will be doing all necessary activities that the user intends to do. So, let us define the operating system, and by now you had understood that it is standing in between the user and the computer hardware. So, whatever the user tries to tell, in turn the OS is listening to it and activating the necessary resources or else activating the necessary programs to do our intended work. An operating system is an interface, it is a bridge between the user and actual hardware of the system. It is a system software which may be viewed as an organized collection of software consisting of procedures for operating a computer and providing an environment for execution of the programs. So, is an operating system a single program? No. So, there are several functions which needs to be catered by the operating system. So, depending upon the functions that we discuss in the later on session, so those sessions depending upon the functionalities, there are several lot of programs binded together in the form of an operating system. It is a set of programs which will be under some particular heading. So, other definitions may be, it may be called as a control program, it may be called as a resource manager, because it is the manager wherein which it is coordinating with all the resources those are at the disposal of the system. It is coordinating, it is managing, it is allocating, then it is relaxing or else releasing the resources also. So, it is a kind of manager, that too a resource manager, which is in between the user and the computer hardware. An operating system is a virtual computer manager, and this is the first program run on a computer when the computer boots up. So, after the OS residing in the RAM, then it tries to control the overall system, that to the resources attached with the system. So, let us take some examples. As you know, Windows is one operating system, Linux, Mac OS, Chrome OS, then OpenBSD. There are several operating systems. Some are proprietary, some are open source software, and some are right now under development by the community users also. So, whatever those are listed on your slide, these are popular operating systems, and they are coming up with several versions also. So, every year or after 2-3 years, a new version with extra features and extra capabilities is coming up in the market, and users are using these popular operating systems. So, first of all, how it provides the kind of help that it wants to give it to the user. It is in the form, it comes in the form of an user interface. So, whenever you switch on the system, it boots up, and then after booting up, a Windows machine will be opening up with the desktop and with the cursor activation. So, whatever the program that we wish to do, or whatever the command that we want to give, or whatever the folder that we want to open, so it is giving you a kind of user interface in the form of graphical. So, in Windows it is providing the graphical user window, graphical user, and in the if you take the case of the Unix or else MS-DOS, so it will come along with the command user interface. So, we have to remember the commands, and we have to put those commands again as a prompt, and then appropriate output will be coming. So, everything whatever we wish to do, the user interface will be created by the user, and we will be running those commands on that particular user interface in order to get the outcome. As we had discussed, there are two different interfaces. One is the command driven interfaces and the graphical user interface. Whatever the commands that we give at the prompt, in MCS in the second semester you had studied the Linux part. So, there we have the shell commands. So, you had worked with several shell commands, and even you had done shell programming also. So, you are interacting with the shell, and then later on shell is interacting with the core kernel, and then kernel is nothing but an operating system which is activating the resources or the hardware. So, all the commands that whatever we wish to give against the prompt, it will consist of a kind of syntax, or else a command, and then along with that you have to put the arguments or the parameter list. So, depending upon the options that we are providing, it will displace the desired input. So, whatever that we intend to give at the shell prompt, every command we have to remember. So, that is the thing that this command driven user interface works with. So, suppose if you give a spelling mistake whenever you are typing the command, so it says that command does not exist. So, everything you have to keep in mind the command what you have to give, the spelling along with the options or else the arguments. So, everything you need to remember, and then you have to place it against the shell prompt. The next type of interface is the graphical user interface. Here everything comes in the form of a graphical icon, or else a text box, a label, or else in the form of folders, in the form of a multi-line text box. Likewise, there are several graphical components available, and we will be working with the graphical components, and that interface is very much easy for the users. So that is the reason why Windows became very popular. So wherever you see the graphical components either in the operating systems or else in the application programs, most of the users attract towards it, and then they tries to do the things with a little bit of training. So no need of a hardcore training, with a little bit of training we will be able to do the necessary commands for the application programs as well as for the operating systems also. So there are two ways to interact with the operating system. One is the operating system calls and the second is the operating system commands. Where lies the difference? First of all, we will study the system command. A system command is nothing but the command that is given by the user against the prompt in a command user interface, or else in a graphical user interface, whatever the thing that we are using it with the help of the mouse or with the help of the keyboard, whatever we are trying to input or whatever we are trying to activate, those are nothing but we are giving the system commands to the operating system. Here you have to remember that user is directly giving the command in order to understandable by the operating system and does the work appropriately depending upon the command. But when you come to the system calls, these are nothing but these system calls can be written either in the programs. So this is not the command that we are directly giving from the with the help of the mouse or else with the help of the keyboard or else with the help of the command at the shell prompt. Here these calls are nothing but these calls are incorporated in the programs. So it invokes the services of the operating system by means of runtime system calls. So suppose if you take the case of C programming, so there suppose if you want to clear the screen, so that particular clear screen function you will be writing it in the C program. That too you should include a conio.h header file. So there you are trying to refresh the screen and afterwards the cursor will blink at the top left hand side top corner, so that the printf command will be displayed and later on the user will try to give the inputs accordingly. So here you can see there are several system calls. Suppose if you want to print certain things not on the screen but the printer attached along with the system, then in the program itself you can activate the you can activate the appropriate system call wherein which it will directly print the output on the printer, not on the video. So these kinds of programs, such small procedures or calls which we write in the programs itself in order to invoke the operating systems, these are called as the system calls. So let us come and understand the basic functions of the operating system. As you can see from the slide, these are important functions. Apart from these functions, there are other functions also, which we consider them as minor when compared to the listed 6 functions. The first function we study is process management, memory management, IO management, file management, security and protection, error handling. So these are basically the main functions of an operating system, of any operating system. Suppose if you take the case of a desktop or else even you can take the case of a mobile operating systems also, these 6 functions holds good. So for mobile also process management happens, memory management, IO management, all these 6 functions are very much holds true for the mobile operating system also. So whenever we talk about the functions of an OS, all these 6 functions comes into picture. So if you clearly look into the structure of our MCS 041, from next unit onwards, unit 2 onwards, you can find each and every function we had prescribed it as a unit. So process management, we had defined it as process management and deadlocks. Likewise memory management, once again it is being split into one chapter. So likewise, depending upon the prominence of these particular functions, we had given you a kind of chapter or else unit in your MCS 41. So, let us see what exactly is process management. So, a process is nothing but the program in execution is called as a process. So, here the operating system keeps track of all the processors. Suppose if a single processor is there, well and good. Otherwise, if several processors are there and several processes are there, once again it has to note down all the status of the processes, whether they are in the execution stage, whether they are in the ready state, whether they are waiting for the IO. Each and every status of the process at any point of time needs to be captured, and it decides who will have a chance to use the CPU. That also it will deals with. And once again the processor schedule, what kind of algorithm it should follow while taking the CPU along with the process, those also needs to be taken care. Coming to the next part, that is the memory management. So, in the memory also there are several. So, one is directly attached with the system, that is the RAM that we are talking about, then ROM is there, then hard disk is there. Suppose if some sort of external devices like external hard disk and pen drive are connected to the system, those also comes under the secondary storages. So, the OS should keep track of the memory, what parts are in use and by which processes. So, those particular things is dealt by the function called as the memory management. Then input output management, or else you can call this one as the device management also. So, there are several resources or devices connected to our system. So, how to deal or else how to allocate and relax those particular resources by the operating system, whom to allot, like which process, to which process I should allocate the printer, to which process I should allocate the like hard disk, to which process I should allocate the magnetic tape. So, all these resources which are disposed to the system, which needs to be activated, deactivated, read, write, whatever the case may be. So, all these things comes under the IO management or else the device management. So, next is the file management. Whatever that we store the information as a entity, the complete information, basic information as an entity, that we call it as a file. And many files together we club them and we put it in the form of a directory in Unix or Linux, and we put them in the form of a folder in Windows based operating system. So, in order to maintain the file status or else tracking of the file on the hard disk, where is it available, at which location is it available, what exactly is the status, and with which prompt we had opened that file, what are the privileges that the file has, and then who is the owner of the file, what is the size of the file. So, all these things whenever the OS tries to coordinate, everything it should keep track of, and it decides to whom to issue or else to whom to it should be allotted depending upon the privileges and other security requirements. Next one is security and protection. First of all, whenever we talk about the security part, the OS itself should protect the user from an unauthorized access of his files or data, and the second thing we have to consider is OS should protect itself also. So, OS should not get corrupted. So, whenever there is a kind of problem with some sort of commands and other things, immediately it should have some recovery procedures or else some sort of messages to be displayed to the user in order to say that this is a kind of unauthorized or unauthenticated access. So, such kind of prompts or such kind of displays needs to be prompted by the US whenever user tries to access the unauthorized access. So, these kinds of activities containing the protection or else security aspects needs to be coordinated by the operating system, and these are clubbed together in the form of security and protection management of OS. Then comes the error handling part. So, an operating system must respond to the errors. It should not allow. Suppose if you want to do divide by 0. So, immediately it should tell you that you are going to this particular thing is about to fail, because it is trying to divide some integer by 0. So, there should be a sort of message or appropriate action need to be displayed or messaged to the user. So, all these error handling techniques and other respected programs pertaining to errors and recoveries needs to be done by the operating system, and those group of programs or software comes under the error handling software of the operating system. So, after looking into the several aspects of the functions of the operating system, let us switch on to the types of operating systems. So, there are several types of operating systems depending upon the activity, depending upon the number of processors, depending upon the number of tasks, or else depending upon the machines that it should coordinate with, either a single machine or machines connected together. So, depending upon those primary factors, the operating systems are divided majorly into batch operating systems, multi-programming operating systems, distributed operating systems, and network operating systems. Let us see one by one in which context we can use these particular operating systems. First of all, we will take the batch operating system. So, whenever we talk about the batch processing kind of thing, so it requires a batch operating system. So, batch processing generally requires the program data and appropriate system commands to be submitted together in the form of a job. So, once they are being submitted to the system, automatically the batch job starts, continues for all the records, and then either it may be a print command or else it may be a kind of generation of pay slips, whatever the case may be, it does it for all the records and then it will come to a endpoint. So, batch operating system usually allow little or no interaction between the users and the execution programs. So, here the interaction part is very minimal from the user side or else from the program side. Once it is been fed in the basic commands for the whole records, then automatically it will carry on for the whole batch records. Scheduling in batch systems is very simple and are processed in the order of submission. Whatever the order that we are going to place the batch jobs, in that particular order it will execute and then give the required output. Here the minimal is the user interaction or else the program execution interaction. So, memory management in batch systems is also very much simple. Once it is given, it is the program will be converted into the form of a process which is residing in the RAM, and it obviously does the whole part of the batch processing. Then memory is divided into two areas. One is the permanently occupied by the resident portion, that is the OS portion. The lower part of the RAM is the OS portion, and then it is used to load transient programs for execution. So, the whole RAM is being divided into two parts, one is for the OS and the other is for the transient program of execution. So, here we can take the examples like payroll, weather forecasting, statistical analysis, Laurel's large scientific number crunching programs. All these programs comes under the should be coordinated by the batch operating system. Coming to the multi-programming. Multi-programming is essentially multiplexing of system resources such as processor, memory and I/O devices among a number of active programs. So, here we are talking about the number of processes. So, there we are talking about the batch kind of thing. So, here there are several processes with several desired outcomes. So, all those things are being basically placed on the RAM, and then the OS needs to play a resource manager kind of role or else a control program kind of role, wherein which at any point of time, suppose if it is having a single processor attached with the system, it should coordinate the CPU among all the processes, likewise the I/O part, or else likewise the queuing part, likewise the context switch part, everything needs to be coordinated in a successful fashion. Then only we can get the desired outputs and the CPU utilization will be more in this aspect. Also, you can have a thorough throughput, whatever that is meant for that system. Then multiprogramming is used as a technique to enhance the throughput efficiency, that is what we are talking about. Overlapping, interleaving computing of different jobs, because there are several processes meant for several things, several outcomes. So those programs are not meant for a single job, those are meant for different jobs, and among them there should be a kind of process communication, if at all it is possible, a kind of process synchronization. Everything comes into picture whenever we talk about the multiprogramming. So multiprogramming operating systems, these are characterized by a multitude of simultaneously active programs that are competing for system resources. System resources are very limited, but processors, they want to use the system resources by several processors. Suppose if a printer is there, the P1 may be requesting the printer, and at the same time P2 and P3 may be also requesting for the printer. Once it is been allocated to the P1, it will be following a kind of algorithm, either it may be preempt or non-preempting algorithms. Depending upon the algorithm, once the printer is being allocated, the next assignment will be to the next process depending upon the algorithm that it follows at the back end. So it monitors the state of all active programs. It should note down the PCB in the form of a PCB, which we will be learning it in the next session, process control block kind of thing. So each and every snapshot of the processes needs to be stored, and then it should also play with the system resources very much efficiently. So there are altogether, we can talk about 3 categories or else 3 types of multiprogramming or operating systems. One is multitasking operating systems, which it allows you to have several tasks, and that too with one processor. And then multi-processing operating system, multi-user operating system. There are a very slight difference between all these 3. Let us see one by one what exactly is the multitasking operating system. So a multitasking operating system is distinguished by its ability to support concurrent execution of 2 or more active processes. So if it is having only single operating system, single process with single processor, and it allows only single process to handle, that won't be called as a multitasking. It is only single tasking operating system. But here we are talking about multitasking operating system. Some programs or some processes we can run either foreground, and some may be shifted to the background. And that too simultaneously we can access the different programs, or else CPU can handle different processes at different timings. So all these things comes under the multitasking. Likewise, suppose if you take the case of a mobile operating system, it allows you multitasking. So it allows you to open several apps, and if you are working with one app, simultaneously you activate another app, and you can work with that app, and you can cut, paste, and then you can bring it to the a kind of notepad app. Once again you can paste it, and once again you can go back to that particular app. Whatever the case, these particular apps, you can talk them as a several tasks, and they are working with under the same umbrella, or else with the same processor, and deciding in the same memory, same RAM. So it is often coupled with hardware and software support for memory protection in order to prevent the erroneous processes from corrupting address spaces and behavior of other resident processes. So in the RAM also, suppose if there are 5 processes activated, so all these things having the boundaries. P1 will be having the low boundary, upper boundary. Likewise, P2 will be started at some point of location in the memory, and it will be having its own lower boundary and once again the upper boundary. Likewise, the OS should maintain all the boundaries, and also it should maintain corresponding PCBs, process control blocks, in order to store the snapshot while context switching. That also needs to be taken care. So coming to the multiprocessing operating system, these operating systems manage the operation of computer systems that incorporate multiple processors. The first one is multitasking with a single processor, but here we are talking about the number of processor increased to more than 1. So these systems are having more than one processor with many processors, many processes. So in the RAM also may be 1, or else RAM also may be having 1 plus. So there are several processes, several processors, several resources, and a single operating system. So all these things needs to be coordinated by the single operating system. So multiprocessor operating systems are multitasking systems, as you can see, but by definition, because they support simultaneous processes execution. So there are several processes attached with several processors, CPUs, more than one CPU. So the job here by the multi-operating system is very tedious, because it should deal with the number of processors, with the number of processors, and that too having a band of resources also. Let us come to the multi-user operating system. So multi-programming operating system usually support multiple users to interact with the system. So these provide facilities for maintenance of individual user environments, require user authentication for security and protection, and provide per user resource usage counting also. So with that particular system, one system having number of processors maybe, that too interacted by more than one user, multi-user, many users interacting with the same system. So many users requires many processes, and those processes in turn wants resource allocation. Likewise, this is also a very tedious job for the multi-user operating system in order to coordinate among the number of users, number of processors, and number of processes with several resources. So in general, multi-programming implies multitasking, but multitasking doesn't imply multi-programming. This particular statement you have to remember. In many examinations also, you will counter this particular statement, and the examiner tries to ask you justify this particular statement. So whenever you know the difference between multi-programming, multitasking, multi-user, all these things, then you will be able to answer this particular question very easily. So distributed operating system. This particular distributed operating system governs the operation of a distributed computer system and provides a virtual machine abstraction to its users. So in this particular distribution system, the systems will exist some miles away. So once the job is being submitted by the user, he doesn't know where it is being executed, and that too the downtime is very low. If you submit the process, suppose if the system fails there, system 1 fails there, automatically that particular job will be prompted to or else transferred to system 2, wherein which without the knowledge of the user, all the job will be done and required output will be given to the user. So the key objective which we have to understand here is distributed operating systems is having the transparency. So when we talk about the distributed operating systems, all the applications that comes under the e-commerce, like the Amazon application, Flipkart applications, whatever the case may be, or else Facebook application, the social media, whatever the social media applications that we are talking about, all these things will be having the distributed operating systems. There the downtime is very low, very less, and even though some of the systems are down, we don't know, and it doesn't hamper the user's work. So automatically the jobs will be transferred to the other systems, and there it will get the things done. Next comes the network operating system. So till now we had talked about multi-programming, multi-user, multitasking, etc. Here it is talking about the network operating system. So machines are connected together and they may be running using a server, and that server needs to cater all these clients connected to that. So network operating system runs on a server and gives the server the capability to manage data, users, groups, security, applications, etc., and also the network functions. So suppose if I am giving a simple command, I wish to use the resource connected to system 2, that is a printer connected to system 2. So it should allow us to use that particular, it should allow us to use the resources connected on the network. So there will be several resources. Here you can see with one particular system with the resources connected to that system till now we were talking about. So when we go to the network, then there are several resources connected to several systems, that too depending upon the privileges, the access rights. So it should allow to use those system resources also. The basic purpose of the network operating system is to allow shared file, a shared printer, a shared drive, whatever that the other system consists of, depending upon the security aspects and the privileges that are being granted to the user. So examples here we can quote the Microsoft Server 2003, Microsoft Windows Server 2008, Unix systems, Linux server systems, Mac OS, Novel NetWare. Likewise, there are several network operating systems. Here we can give them as the examples. Then there is other kind of systems which are called as the time sharing systems. So here till now we were talking about a kind of algorithm wherein which depending upon the algorithm the processor are granted the CPU. Here this is a kind of typical example wherein which the time sharing system is a logical extension of multiprogramming. Multiple jobs are executed simultaneously by switching the CPU back and forth among them, but here the switching will takes place quantum wise. There will be a time slice for each and every user. He will get his own time slice, that too in some nanoseconds or very less, and then the processor will assign to the process intended for that user. Once again, after the time slice given to him is over, it will switch on to the next user, it executes. Likewise, all the users will share a particular time constraint or else a time slice. You can call it as a quantum of time also. So user can interact with the program while it is running in time sharing mode. However, when we work with the time sharing systems, even user cannot know that right now it is working with my process or working with the other person's process. So that the minimum time has been given that we can't even notice. We will think that the machine is assigned to us only. But there inside there will be a kind of round robin algorithm following, wherein which it caters to all the users with the time slot mechanism. So the other kind of systems we can talk about is the real time systems. So here you can notice real time. So the response should be very much real and immediate. There should be a spark response for the events that are being triggered out. Suppose if it is unable to handle such kind of requests, then there may be a hazard happening. Like suppose if you take the case of a industrial control, wherein which immediately something should happen whenever a trigger or whenever an event happened. So immediately it should take action, immediately it should take prompt action depending upon the events those are appearing. So immediately it should switch on to the event handling. So there may be, suppose if a wrong event is handled or else if the event is handled at a later on time and there is a delay or latency you can call. So if those things are being happening, then some sort of hazard will be there. So for such kind of systems, a typical operating system is required, that is the real time operating systems. So the systems that we can quote for that RTOS are industrial control, telephone switching equipment, flight control, real time simulations. So all these systems comes under the real time systems. So before concluding this particular session, let us recap. So we had started with the four components of the computer system. We had identified all the four components. We had discussed what is the significance of an operating system, where exactly it lies, what kind of interface it will provide to the user and between the computer hardware, and then we had talked about the user interfaces, the command user interface and the graphical user interface, and later on we had shifted and identified what are the main and essential functions of an operating system. And in the later part, you had studied about a number of operating systems like categorized depending upon the use and the roles. So, with this we will come to end of the unit 1 of MCS 041 operating system, that is introduction to operating systems part, and in our next session we will see the processes management. With this I will conclude the system. Whatever the check your progress exercises that are given in your first unit, please attempt all the check your progress exercises. Apart from this, we had already discussed some sort of history of operating systems also in the first unit, just to throw some light on the history of the operating systems also. It is very much easy to understand by you. So, in the next class we will deal the processes management. With this I conclude the session. Thank you very much.